Good morning, everyone, and welcome to our webinar. Just while everyone's filing in here, want to introduce today's webinar. What you're viewing right now is the third part in our educational webinar series, selecting the right tools for your application. This part is going to cover some of our torque applications and also our rotational press basics. So covering some applications with those two units that Promess provides. Just some housekeeping stuff. If you've attended the webinars before, this won't be new to you, but the sidebar on the right-hand side of your screen is used for asking questions. So if you have any questions during the presentation that you'd like to ask the presenters, we will be having a question and answer period at the end where we'll cover as many as we can get to. So today I have, my name is Ed Stockline, by the way. I'm an application and sales engineer here for Promess Incorporated. Today, presenting this presentation, we have John Derry, who's an applications engineer, as well as Neil Suva, who is a mechanical engineer for Promess. Good morning, guys. Just want to go over real quick who Promess is and what we're about. So just a real quick introduction to Promess for those of you who don't know who we are or what we do. A lot of this will be the same stuff if you've attended the other webinars that you've heard before, but just to give you a little synopsis of Promess, we started as a company in 1984 focused on the tool monitoring and machining industry. When that business started to leave the United States, we had to adapt to survive, and we used some of that same tool monitoring technology and brought that into the assembly world with our servo press actuators, our monitoring systems. So to give you guys an idea, we've helped thousands of customers across the globe eliminate quality issues, or achieve reduced cycle times, downtime, operator fatigue, all while increasing the safety and production output of each plant that our projects are in. So what that means for you guys is Promess has technology that has really pushed the forefront of manufacturing. We are the industry leaders in terms of, servo press technology and assembly technology. And a lot of what we're going to share here is the expertise and the knowledge that we've gained over the years. So if you do have an interest in the topics or applications that we cover today, certainly please let us know. There will be a survey at the end, or you'll actually receive an email survey after this, which will allow you to kind of tell us how we did on this webinar and even suggest topics for future webinars. So if you're interested in becoming involved in helping us generate content, that's one way that you can give some feedback. And with that, I will turn the presentation over to Mr. John and Mr. Neil, and I will talk to you guys at the end of the presentation.
Good morning, this is John Derry. Today we will be taking a look at the torque systems offered by Promess Incorporated and discussing what applications might be a good fit for a servo-controlled torque system.
This is Neil. All of the systems are fully electric, no hydraulic fluid or air lines are required. The Torque Pro is a servo motor driven rotational torque assembly and testing tool, which provides rotational and torque feedback. The EMAP is our electromechanical assembly press, which provides linear position and force feedback. The REMAP is the marriage of the two. REMAP stands for Rotational Electromechanical Assembly Press. It combines the Torque Pro and EMAP to provide the capabilities of both in one unit.
So first we're going to take a look at the Torque Pro. Our Torque Pro is scalable based on the application's required torque. Our standard offerings are from 2 Newton meters all the way to 11,000 Newton meters, with other sizes available dependent upon the application. So our Torque Pro is fully rated. It can achieve and maintain the full rated torque capacity. So if you have a 20 Newton meter Torque Pro, it can be used up to 20 Newton meters. It can hold 20 Newton meters. The Torque Pro has integrated torque transducer with an accuracy greater than 1% of nominal. It's fully programmable. Some of the options in the program are to move to a position, which means the Torque Pro is able to move a specified amount. This can be set as rotations, degrees, or even relative values based off other program functions. The Torque Pro also has the ability to move to a specified torque value. We call this a move to signal. The move to signal can also be used to move to any external sensor value, such as a digital probe or flow sensor in a valve type check. It also has the ability to move to or home to an external proximity switch. Generally, this is used for applications where it's desirable to have the tooling in a specific orientation at the end of a cycle without having to rotate back to zero, or this can be used when there's need to zero the positional reading mid-cycle for relative moves. When to use a Torque Pro. When you'd want to use a Torque Pro when rotational assembly or testing is required without the need to move the Torque Pro to the part. So there's no linear movement in this process. Some of the common Torque Pro applications are testing backlash in a gear-to-gear interface or a spline interface, testing torsional stiffness or torsional rigidity of a shaft or other components, measuring torque required to turn an assembly, or adjusting a fastener based on external feedback. Lash is one of the most common applications we see the Torque Pro used for. Lash is very important. It's performed to determine tolerance or play between two components in an assembly. The most common application for lash testing is on gear sets. Single point or static backlash testing holds one gear fixed while the other is rotated to a specific torque in both directions. The positional difference between positive and negative torque directly correlates with lash in the assembly. Multi-point or dynamic backlash testing in a gear assembly while it's moving or at multiple positions. This allows lash to be measured through the range of the gear mesh rather than just one tooth interface. Gear drives need to have the correct amount of backlash. Too little backlash and the gears can bind or become noisy, and too much puts the contact surface on the tooth too far out. This increases the moment on each tooth and can also cause collisions between the teeth while switching directions. This will reduce the overall life of the gear drive. Spline backlash testing is very similar to a gear drive. However, in most cases, it is done using a single point backlash test. Very similar to backlash testing is stiffness testing. It's very closely related to single point or static backlash testing. One end of the shaft or component is held fixed while the other has a specified torque applied to it in both directions. The positional difference between the positive and negative torque values can be used to determine stiffness. Another method to determine stiffness is used, we basically would graph the stiffness of the part, calculating the slopes and the positive and negative torquing. From these slopes, we can determine the stiffness and the hysteresis and make sure the part is within the elastic range. Another very common application for the Torque Pro is torque to turn or torque to rotate testing. Torque to turn testing consists of rotating an assembly or component a defined amount while monitoring the peak and average torque developed while completing commanded rotation. Some examples of torque to turn rotate testing are bearings. Rotating bearings or assemblies utilizing bearing interfaces to determine that the torque to turn them is within specification. This allows defective components or alignment and tolerance issues to be detected before the part leaves the station. Another example of an application where a torque to turn test is used is in an engine assembly. Crankshafts can be rotated to determine if the torque to turn is acceptable. This is used to verify that main bearing clearances are within specification and the crankshaft has the proper freeness after the main bearing caps have been installed. These sort of tests can be used similarly in other driveline components such as a differential or a transmission and transaxle. Some appliances also use this sort of test to determine if the detent that a washing machine or oven has is within the correct amount for the operator or end user to open and close it. This can help determine if there are issues with clearances within an assembly due to part stack up or improper assembly. Another application we do frequently see is screw efficiency testing. Screws such as ball screws or roller screws can be tested for efficiency by placing some form of weight or load on the ball nut or roller nut and rotating the screw to determine if the effort needed to rotate correlates with the force or weight applied.
The remap is rated to full force and torque with high inertia capabilities. Features internal force and torque measurement, has fully programmable motion, and offers independent or joint axis control. We will go over these capabilities further on the next slide. Fully rated. The remap is built for 100% duty cycle, so it can be run continuously at its full rated force and torque. Internal measurement. The force and torque accuracy of a remap unit is slightly less than that of an individual press and torque unit. The accuracy is slightly lower due to the inherent frictional forces created by joining the two axes. Fully programmable. Absolute, incremental, or continuous moves, move to a force or torque value, move to an external signal or reference, or move to a function. We will explain some of these functions more in depth when we go over some applications. Independent or joined axis. The remap coupled with the multi-axis Promess Ultra Pro controls package allows for individual axis control and synchronized motion between multiple axes. Multi-axis control and synchronization is not limited to the remap. The Ultra Pro system can control and synchronize any combination of Promess linear or rotational actuators. Many manufacturers offer multi-axis controls. When selecting a control package for multi-axis systems, it is often very beneficial to look for synchronized axis control. Now let's look at some typical applications for the remap. Torque unit engagement. A common example is tightening a threaded fastener, where the rotational axis is moved linearly to engage the head or body of a fastener. Threaded interfaces. The remap is very well suited for threaded assembly due to its abilities to synchronize the linear and rotary axes to match the thread pitch. Force feedback allows for the unit to find the start of the thread, which aids in preventing cross-threading. Other common uses include thread testing, tapping, and screw efficiency testing. Rotational assembly. This can be indexing a spline or keyed interface. Force feedback can be used to find the correct index angle and then extend to engage. This can be used for lifetime testing as well. Testing an e-stop switch that is pressed and requires rotation to disengage, or inserting and rotating a key into a switch or latch to simulate prolonged use. Multi-direction loads. One notable application is angular contact bearing testing. Bearings can be held to a specified preload while rotating to analyze torque to turn values. Another valuable use is seal pressing. During insertion, sealing lips can get hung up or inverted, compromising the seal. Rotating during installation eliminates the majority of these errors. Looking at the torque to turn value, once installed, provides a verification that the unit is seated correctly. Actuating to a function. The preload on an angular contact bearing is critical for performance and longevity. Traditionally, this is verified with a torque to turn value, but bearing lash measurement often has a more direct correlation to preload. Both methods can be performed with a remap to close the loop on assembly, actuating to a functional value. Another simple example of actuating to a function is tightening a hinge while it is actuated. The press coins a hinge assembly or tightens the hinge bolt until a given torque is required to swivel. Actuating to a function capability is standard on all Promess equipment. This feature has allowed for the simplification of complex assembly procedures while decreasing variations in assembly functionality. This video is showing one of our backlash adjustment applications. The video will repeat, so if you miss it the first time around, you should have another chance to see it. First, we use a servo to press the shaft to a force, then pull in the opposite direction with the same amount of force. We have a digital probe reading directly off the part, taking a measurement where we can reach the force in each direction. When we've calculated the current backlash of the system, we can use a lookup table in the software to refer to how much we need to torque the nut to achieve our desired lash. These values are typically based off of previous testing. Another torque unit is done. After the torque unit is done with the adjustment, we check the lash again and have the ability to make any small adjustments in the remaining lash is still out of specification. Another cool feature of this video is it shows our hollow shaft torque probe, which is hollow through the motor and allows to bring a press and probe through the middle to test the lash in the setup. These are a few of the benefits to this type of setup. All the adjustment is automated. There is no operator to think it's too loose or too tight. Adjustment is done right on the machine. No need to pull the part out of the cell to manually test the lash. The results are repeatable. With a machine that can think and feel making the decisions, the part comes out the same each and every time. Precision injection molding. The remap's linear and rotational axes can be used for plastic injection into vehicle safety components. These components are designed to break free when subjected to extreme loads to protect drivers from injury. Utilizing a servo system rather than a typical hydraulic system allows for precise control of force during injection and solidification of the plastic. This can be used to improve the performance of the finished product and identify defects before the process is complete. Spring-loaded assemblies. Most commercial door closures require threaded assembly to hold a spring-loaded mechanism in place. The remap has been very beneficial to preload the spring and thread the cap in while monitoring preload force and thread engagement. The preload along with the fine thread prevents the operator's feel for correcting the thread when done manually. Joint axis control eliminates this potential for cross-threading. The applications mentioned are just a handful of examples where the remap is used for assembly and testing. The remap is available in a variety of force and torque combinations to fit most torque applications. Promess has also developed various add-ons and special equipment, especially for demanding applications. The High Positional Accuracy Torque Pro was born out of the need to detect minute backlash in various geared systems. Though the standard Torque Pro is a precision device to begin with, this version offers up to 45 times better positional accuracy and resolution. To improve the lower torque accuracy of the remap, we developed an external rotary torque sensor which has a full range accuracy well below 1%. The same technology was utilized to develop a high accuracy Torque Pro, capable of measuring low torque values with a high degree of accuracy. If you think you have a specialized torque application, you can reach out to us after this webinar to talk with our engineering team. Choosing a rotational and/or linear actuator. It is important to consider the following when selecting an actuator for your application. Force and torque range. What are your average, minimum, and maximum values? Force and torque accuracy. What is the required accuracy for pass, fail, or verification? Speed and acceleration. Does the process need to be run at a certain speed? Are there any cycle time requirements that need to be taken into account? Part and tooling inertia. This is a big consideration for torque units especially. A torque actuator needs to be able to control the rotating load accurately to prevent oscillations or overshoot. One issue we see somewhat often is heavy tooling on a relatively low torque unit. Providing even a ballpark part tooling inertia to the manufacturer during the selection process can simplify the overall setup and improve long-term functionality. Rotational backlash. Are you measuring backlash? Can the actuator itself have backlash and still perform the operation? One side note here, an actuator with backlash can be used to accurately test lash in an assembly. High-level control software can remove the characteristic backlash of the actuator in the test data. These are some of the most important details that should be taken into account when selecting an actuator.
Great, thanks guys. So now we'll move into the question and answer portion of the presentation. We already have a couple questions. I'll throw them to you and Neil separately, John. If you guys do have questions, feel free to use that pane over on the right side of your screen on your web browser and Teams to ask questions, and we'll try and get through as many as possible. Let's see here. So the first one we have here, I guess we can give this to you, John. So someone asked, what speed do your torque guns run at? And I guess I'll throw a separate question at you, and why we don't call our units torque guns.
So our torque systems are rated at 250 RPM standard. We can customize those with different motor and gear packages to achieve the desired torque and RPM needed for the application. We tend not to think of our torque pros as a torque gun because they're generally not used for threaded assembly the way a torque gun would be. They're more for fine adjustment or testing applications.
Cool. Neil, does the remap use a ball screw?
The majority of the remaps do. The lower force units use ball screws. However, the higher force units, such as the 40 and 60 kilonewton, use roller screws.
And we didn't really cover the mechanics of the actual remap, but what allows us to rotate while extending the press side of the remap?
The remap is based around a rotary spline, so it allows us to couple the linear and rotational axes while still maintaining their independence. So our linear axis moves the spline, and then the rotational axis actually rotates the spline.
This could be for either of you. Do you account for the friction of the system when measuring torque?
Oftentimes in remap applications we need to, just because of the internal friction created by joining the two. And what we do for that is we typically will rotate 1, 2, 3 times and kind of measure the characteristic frictional torque of the unit. And then with our software, we can remove that from the data when we do an actual part.
I apologize if I mess up your name, but Merly asks, move to signal option on the remap. Can you stop the linear travel based on the torque feedback? How repeatable is that?
You can stop the force axis based on torque feedback. The UltraPro software that's used to control the remap allows for signal inputs for various moves from any sensor that's connected to it. Repeatability is a difficult question to answer, mainly because it depends on the speed you're moving at. If you're going to move at full speed, then typically there's a little bit of overshoot. But if you have the time in your process to run slower, then we can pretty much hit it dead on.
And I guess I would add on to that, if you do have a special requirement that may require a certain touch to your, or a certain amount of sensitivity to your application, certainly that's a discussion that any of our applications engineers here are willing to have with you. Someone said, can you talk about the controllers? Maybe John, typically we use, like, say, Motion Pro for a single axis Torque Pro, and then our Ultra Pro system for the multi-axis.
That's correct for the most part. So one benefit to using Ultra Pro with the Torque Pro, the Ultra Pro has the ability to monitor or record data in both directions. So something like a stiffness check or a lash check, there are benefits going with the Ultra Pro. Where the Motion Pro still has the capability to record that, you would just see that in two separate curves, one being from 0 to positive torque and the other curve being from 0 to negative torque. You would then have to kind of extrapolate that data and combine the two in a way to view it. The Ultra Pro allows you to view that all in one window, and you can also use that to kind of differentiate both directions with separate colors, which is nice. And for remap applications, we definitely recommend the Ultra Pro because it has multi-axis capabilities and allows you to use the axis in a joined function that Neil described, such as moving the linear axis as the torque is rotating to compensate for thread pitch or something like that.
Okay. I think that probably covers Javier's question. So he asked, does each Promess press use the Motion Pro software to control? How do they interact with each other? Typically on, and I'll answer that one, I guess, is on some of our older applications before we used, or before Ultra Pro was even a thing, we did use Motion Pro controllers and had a special I/O that was able to talk between the controllers. So yeah, certainly we have many solutions to the same problem for a lot of those multi-axis applications. Alan asked, can a remap or torque system be mounted upside down?
There is really no way that it cannot be mounted. It could be mounted anywhere within 360 degrees. There's no real concern with that. As long as the remap doesn't have heavy tooling weighted on it, if that were the case, we'd recommend using a brake for the linear axis.
Cool. All right, I think that pretty much covers the question portion. Let's move on there, Neil. Okay. Yeah, so just to close up with everyone, we do want to thank you for attending. You can reach out to Promess via our email, our website, or give us a call if you have a application that requires torque or the remap system, if you need that extra linear motion as well. You can get our information as well on any of our social channels. And if you follow them, you'll get regular updates on the content that we're producing on a pretty regular basis, especially during this time. We're trying to produce some more educational content during this whole COVID thing, because we know a lot of you are either working from home or have some extra time during the day to dedicate to, bettering yourselves and learning a little bit more on the side. So with that, I do want to thank everyone. Certainly reach out to Promess if you have any questions, and have a great day.